Okay, so I've got this recording. There's gonna be a couple minutes of blank time. We'll wait for everybody to get here. But as we go through this video, if you're watching it later on, pay attention to when I say this is reaction 1, reaction 2, reaction 3, and so on. You're gonna want to take some notes as you go through this. Because we're going to kind of go back and forth. There's a couple reactions that take some time, so we're going to get them started and then come back and check on them towards the end of the video.
Okay. That didn't work. I thought you'd be done.
Let me start at 1. Okay, so I'm going to go ahead and get started on this lab demo. I'm going to go through several different types of reactions. So I'm going to go through a synthesis, a decomposition, a single replacement, a double replacement, and then a pretty simple combustion. So as I go through this, if you have questions, feel free to email me or comment on Google Classroom, and I'll be happy to answer those. All right, so first thing we're going to do is we're going to start with a synthesis reaction. So there are different types of synthesis reactions we can do. The one I'm going to look at is creating rust from steel wool. So steel wool is primarily iron. The formula for it is basically Fe. And if you purchase commercial steel wool, it has an oily coating on it to protect it from rusting. So what I'm going to do is I'm going to dip my steel wool in vinegar. Okay. And then I'm going to wait a little while and see what happens. Okay. And this reaction takes a little while to go through, but over time it's going to change from the silver solid. You can see that. and it's going to start to change color and appearance, and it starts to smell also. Okay. It also started with a mass of 4.26 grams. When I first put it on the scale, that's about how much of this I had on there. And we're going to see what happens to the mass of the steel wool over time. We're also going to see what happens to the temperature of the steel wool over time. So it's got an initial temperature of about 20 degrees Celsius. I'm going to put this thermometer pretty well inside here. Okay. And then I'm going to check this temperature again in about 5 minutes. And what should happen is my temperature should change, indicating that there is a chemical reaction going on, and my steel wool should change in appearance. Now, like I said, that one takes a while. So we're going to set that one to the side for a while. This is reaction 1, and this is your synthesis reaction about steel wool. And we'll check back in about 5 or 10 minutes and see what happened. And always wear gloves when you're handling steel wool, by the way. I did it earlier, and I got steel wool in my hands, and it hurts. So, all right. Reaction 2. So the second reaction I'm going to look at is a decomposition reaction. And remember from the videos, decomposition means breaking something apart. So just like something decomposes over time, it's like food or whatever, it breaks apart into smaller pieces or different chemicals. And what I've got here in this test tube is called copper carbonate. And you can see it is a bluish teal solid. It's kind of and it's powdery. And so what I'm going to do, I'm going to bring over my Bunsen burner, and I'm going to gently heat my solid. You always want to make sure you use tongs to hold this so you don't hurt yourself. Okay. We're going to heat it for a few minutes, but as you can see, it's kind of changing. You got a black substance forming on the bottom. You don't want to get it too hot. But what's happening here is the copper carbonate is breaking down into what we call copper oxide, which is the black substance on the bottom. And then I don't know if you can see, there's like a little condensation almost. But there's a gas forming as well, and it's carbon dioxide. So after I heat that for a bit, I'm going to light a wooden splint on fire. I'm going to insert it into the test tube, and it goes out immediately. And then it comes back on, and then it goes out. And the reason why it's going out is because that carbon dioxide that was formed from our decomposition is causing our flame to go out. So in order for something to burn, it has to have oxygen. It has to be in the presence of oxygen. If it's in the presence of carbon dioxide is a flame suppressant. So it's going to put your flame out. Okay, so that one is decomposition. That's reaction 2. So we heated our copper carbonate. Started as a nice teal solid. We heated it, it turned black, and produced carbon dioxide gas. Okay. I'm going to remove that Bunsen burner and get that out of here. All right. The next reaction I want to talk about is a single replacement reaction. And we're going to do a little bit of swap out magic here, just like we do on cooking shows or whatever. So what I have in this test tube is copper wire, okay? And I'm going to add to the test tube what we call silver nitrate solution, and it's what we call aqueous, which means it's dissolved in water. And I will post the chemical reactions, the chemical equations online when we're done with this experiment. So look for that as well. Okay, so what I'm going to do, I've got my copper, and I'm going to pour a little bit of silver nitrate in the bottom. And you can see right now the silver nitrate is completely clear and the copper is still copper colored. It hasn't changed. Okay. This reaction takes a little while to take place. So we're going to check back on that in a few minutes. Okay. So over time, and this is what I put in this morning, what happens is you can see our solution went from being completely clear to kind of a light blue. We'll put the white up to it so you can kind of see it's light blue. Also, our copper wire, if you look at it, you now have a silver metal, and this is actual silver, that has formed. So if I were to pull it out, you can see how the copper has been replacing the silver in the solution. So the copper is going into the solution, and then the silver is becoming a solid. Okay, so this is what happens. This is after like an hour, 2 hours. And here we go. This is the one I just started just now, and you can kind of see that formation taking place, right? So you can see, if I pull this out, you can see how it's changing color. It's starting to look like something's happening. We're just going to let it hang out in there, and you can kind of see stuff happening. Okay. By the way, our steel wool has jumped up to 22 degrees, so it's gaining some temperature. If I look at it, it's also sort of changing color. It also smells really bad. But you can see it's kind of getting a rust color to it. It's kind of turning yellowish. It'll be more dramatic here in a little bit. Also, if I look at it, it started out with a mass of 4.6 and it's gaining, or 4.26, sorry, and it is gaining mass. And we'll talk about why that happens here at the very end of the video. Okay, so we have done a synthesis where we're forming a product. It's our iron with oxygen making what we call iron oxide, or rust as we know it. We have done a decomposition where we broke down copper carbonate into copper oxide and carbon dioxide. So it forms 2 smaller compounds. We've done a single replacement where we take silver nitrate and copper and they swap places. So copper takes silver spot. And then what we're going to do next is a double replacement. So single replacement was where one guy comes in, like copper is a single ion or a single element, it comes in and bumps somebody else out. Double replacement means you have 2 compounds and they're going to switch places. So I'll grab my compounds over here. So I have got copper nitrate, which is a clear blue solution. Okay, it's a really pretty color. And then I've got sodium carbonate in this test tube, and sodium carbonate is just a clear solution. Okay, so I have 2 solutions dissolved in water. Okay, so now what I'm going to do is I'm going to pour my copper nitrate into my sodium carbonate. And you can see what happens instead of them being nice, clear, and blue, they form this chunky solid, this chunky blue solid. So this solid part is called a precipitate, okay? And you can see how it's really like, it's not a nice, pretty solution anymore. Here was the original bottle of the blue. Now it's like chunky and funky looking. Okay, so this is called a double replacement reaction. So what happens is instead of the copper being bonded with the nitrate and the sodium being bonded with the carbonate, they switch. So the sodium and the nitrate come together and they form the liquid part. And then the copper and the carbonate come together and they're not soluble. They can't dissolve in water, so they form this chunky solid in here. Not all reactions will take place when it comes to trying to do a double replacement. Sometimes you'll mix two solutions together and nothing will happen because they both dissolve in water, and so you don't get a solid. So in order to be a true double replacement, you have to have a precipitate, which is what this is called, or a solid formed. Okay. And I don't know if you can tell on the camera, but this is like really chunky. All right, so that was our double replacement. Double replacement. All right, the last experiment I'm going to do for you guys is a combustion. And a combustion reaction is burning. One question a lot of people had about combustion is, why is water formed? Well, a lot of that has to do with the rearrangement of atoms. So, for example, when we talk about burning something, we talk about a hydrocarbon. Hydrocarbon is just something that's made up of carbon and hydrogen. And those are like the only elements involved in it. Or sometimes you'll have what we call alcohols, which is carbon, hydrogen, and then it has oxygen with it. And so what happens when you burn them, they react with the oxygen, and then the bonds split up. So the carbon and the hydrogen are bonded together. But then the oxygen comes in, and so some of the carbon goes with the oxygen to form carbon dioxide. The hydrogen goes with the oxygen to form water. And we don't really think about water being a product of fire because you don't see it, but that's because it's vapor. It's in a gaseous state. Sometimes if you burn stuff and then you like put, if you put something that's burning into like a glass jar or whatever, and then you'll see the water vapor forming outside condensation. I'm not going to do that, but we can do that. Let me see it. Okay, so burning alcohol. Now, one thing about burning something like isopropyl alcohol or whatever, you have to be really careful. Make sure you put the lid on the container and move it out of the way, because it evaporates quickly and you can set other things on fire that you don't intend to. And I'm going to light it. So you see I have this nice, beautiful fire. And I'm just going to let that go. But this is combustion. Anything that's burning is combustion. And you have to have oxygen in order for the combustion to take place. And it's just going to keep burning until all the alcohol is gone. Now, if I were to cover this, what would happen is I would remove the oxygen source, and so I wouldn't have any more fire. So you see, I can kind of put the fire out. I'm just going to start back up and give it some oxygen. And we're going to get that smothered. Okay? And then eventually it's all going to burn off. So my fire's gone out because I starved it of oxygen, so it can't react anymore. And you can't really tell in the video, but I do have a little bit of water vapor that, as this pan has cooled, has started to condense on the bottom. So I can see my water. But it comes out because of the heat that your fire produces. As it's reacting, it comes out as a vapor, so you don't actually visualize it. But there is water there. All right, so let's check on our steel wool, because this has some time now. So, by the way, it smells really awesome in here. Just telling you, you guys are missing out. We will get a chance to see some of this in person when we get back to in-person classes. Hopefully next week. So, our steel wool, it ended up with a final temperature about 25 degrees. So, this is what we call an exothermic reaction, which means it produces heat. And if I look at it, it started off nice and silver. And now, if you can see, it's sort of this brown, nasty, brownish red color. I don't know how well you can tell this in the video, but it is a definite brownish red. This has definitely changed color. It has also changed in mass. So I started with about a 4.5 gram piece of steel wool, and my final mass ended up being around 5 grams, 5.5 actually. So it gained mass, and the reason why is because it took on oxygen. So it pulled oxygen out of the air, started with just iron, it pulled oxygen out of the air to become iron oxide. Okay, so those are your 5 reactions. Your synthesis reaction, which was the steel wool reacting with oxygen to form iron oxide. And it went from silver, kind of a silverish color, to a rusty brown. The mass of your steel wool piece changed because it took on those oxygen atoms. And the temperature increased as we went through the reaction due to the reaction producing heat. Okay, our second reaction was our decomposition. That was where we heated copper carbonate. It produced copper oxide, which is this brown, darkish, kind of black almost, and then carbon dioxide gas. Our third reaction was our single replacement. This one's coming along nicely, where we started with copper wire and a clear silver nitrate solution, and it formed copper nitrate, so the solution turned a little bit blue, and then we've got silver forming on our wire, and you can see it really well right now. You can see that silver down there on the wire. Okay. Our fourth reaction was our double replacement, where we started with the two solutions, the blue solution and the clear solution, and it turned, when we mixed them together, we get this blue solid form. So this is where the copper nitrate and the sodium carbonate mixed together to form copper carbonate and then sodium nitrate. So it's a double replacement. They switched places. And the solid is called a precipitate. And so it went from solutions to this chunky, cloudy mess. I think this might give you a better picture of it. I don't know how well you can tell. I poured some of it out. You can see the solid there. Okay. And then our fifth reaction was combustion, where we burned our alcohol to produce carbon dioxide and water vapor. So as you go through this, take notes over this and then fill in the questions on the Google Slides for tomorrow. I'm going to go ahead and post those slides today. So if you want to get it all done today and then you don't have anything to do tomorrow, that's fine. If you have any questions or concerns, email me, and then look also for a slide that has the equations, the chemical equations we use for each of these reactions. All right. I hope you guys have a good day.